devise those four traversal functions utilizing the function pointer. So here, let's define a function, void function 1, and then as an integer is provided, what I want to do is give a square bracket, then value, and then close square bracket, and then one blank. That's what I want to do. So when you do traverse, I just provide function 1, there. So inorder function, when you do traverse, when you visit each node, just activate the function 1 by providing the value at the node in this parameter. Then the function 1 is defined by the user of binary search tree instead of it's part of the binary search tree implementation. Yeah. So let's modify that way. Here, you cannot just give any arbitrary function, but there is a limitation. So any function which has a void return and the one integer parameter could be passed there. So here, in a public interface of inorder, so we need to give the parameter definition. A function pointer is provided, so it should be in parentheses star, and any function pointer is there. And this function pointer return type is a void, and it has a one integer is there. When you define a function parameter here, inorder, this is a function parameter, like erase as a parameter is int. So the whole thing is a parameter of inorder. When you give a parameter, the parameter name is optional. So in this definition, f is the name of the parameter. So we can skip that part. So function pointer as a parameter, eliminating the parameter name, so inorder is defined. So let's go to the inorder definition. So inorder, now we are defining on a function. We have to give a name of the parameter though. So here, what you do is void return, and then function name is f, and then one parameter. So we define function pointer for inorder, and then when you call the inorder function, whatever function user defines is provided. So recursively we call inorder, then we need to pass the parameter. So that's a function pointer f is a parameter, so we call with the whatever provided a function pointer value. Then inorder recursive takes another parameter, so we need to update inorder recursive, which takes also void function pointer, which has one integer parameter. Again, this is a function prototype, so we can eliminate the parameter name. Then inorder, now we need to define void star f integer type. We define the second parameter accordingly. Now f is the one, so when whatever function pointer is provided, it's passed to recursive version there. Then when you call recursively, whatever function provided, we need to pass it to. Then instead of directly printing on the screen, we can just activate whatever function called. So activate the function call star f. We call the function, whatever function is provided, and then parameter of the function call is the data at the root node. So that's what we want to do. Whatever function provided, just call it. So let's test it. So now each data is wrapped up by square bracket. So that's what we have modified there. So Similarly, you can update pre-order and post-order, which takes the function pointer instead of you do predefined ones there. So based on this one, let me show you another application of this. So what I want to do is I want to compute the sum of all the integers in the tree. Then you can visit each value with the inorder, and then by designing the function passed for the processing of each node, you can compute the sum as well. So let's define a function. Whatever integer is provided, then let's have a global variable total as a 0. Then in this function, what you do is a total and is accumulated into total, something like this. Actually, when you call the function, what you could do is as follows: t1 in order and call some function there. So we can pass any function which has a return type void when one parameter is there. And then this parameter will be fed by value at each node, and then we can compute the total. After that, we can say cout total is a global variable total. So let's run the program. And total is 183. So if we add all of those together, that would be the total 1. And then if you want to compute that, int s is 0, and then s is data I. You can locally compute the sum, and then at this moment you can do assert s equal total. You can compare the result there and then run it. So assertion is successful, so we can compute some other things. We can do some other, whatever function the programmer provides, the inorder traversal just invokes the provided function for each node. So that's the power of utilizing function pointer in traversing. So you can do same thing for pre-order, post-order, and breadth first traversal as well.